In this tutorial, we'll cover the basics of network transports in MADARA and how to coordinate with other agents in a network to send information and files. We'll also cover the evaluate, wait, set, and print knowledge mechanisms in MADARA. We're not going to be covering how to set up a MADARA project, and will instead work from the First Steps project we created in the First Steps tutorial video. If you've not already done so, please view that guide for information on setting up the include and libpath directories for your compiler to be able to locate the appropriate header and library files for MADARA. To help in getting started with networking, we provide several projects in MADARA's test and tutorials directories that serve as excellent source material for jump-starting a project. Here we open up the Multicast test and counting agents tutorial source code to help us create a multicast application. We use one of the 239.255 multicast IPs and adjust the MADARA transport settings class to specify a multicast transport. Again, there are a lot of examples in the test and tutorials directories, so feel free to copy and paste code. We also make sure to modify the knowledge base constructor to use the transport settings class and a default host setting. With only a handful of lines, the knowledge base is now initialized for a multicast transport. Next, we compile the project to make sure that our changes take effect, and as we can see, the build was successful. Now that the transport is set up, let's try to send some data over the multicast IP we specified. The MADARA project includes some test images, and we'll go ahead and use one of them that I took at a hotel in Brazil. We copy the image to a new directory called images in the root directory. I'm copying the image over to this directory for convenience. You can use whatever directory you like as long as you remember the path to the file. We add a read file call here and specify that the file be read into a variable called image. We then print all knowledge in the knowledge base and compile the application. When we run the application, the print knowledge command informs us that the variable image is a binary of a specific size. Let's add another variable called sumVar that we simply set to 1.0 in order to show what other primitive types print like. Unlike the variable holding the file, sumVar prints out its value. For most primitive types like strings, integers, and doubles, MADARA will always print out the value, not the size. Both of the variables we used earlier were global variables, which are disseminated through the network transport. There's also a MADARA concept called local variables, which are prefixed with a period. These local variable changes are kept private and local. The test multicast code that we opened earlier uses a local variable called .id, which keeps track of the identifier of the agent participating in the test. This seems like a useful variable to have, so let's go ahead and copy that code over, as well as some code to allow us to set the .id from the command line. After these changes, the user can provide an argument to the program like 0, 1, or 2, which will be set into a convenience variable called id in our transport settings. We then set that in the knowledge base. Another interesting feature of some of the MADARA tests is the ability of a MADARA program to wait on other agents to launch before executing important code. In other frameworks like MPI, this is called a barrier. Let's go ahead and add a barrier that uses the ID we set and waits until another agent is listening before we send our image. To accomplish this, we add a wait statement. Our wait statement first sets a global variable that specifies that the current agent is ready, and then initializes a counter that will keep track of how many total agents are ready to receive the image. The semicolon greater than symbol you see here is called a choose right operator, and it means that the MADARA engine will return the rightmost value. So what this wait statement is ultimately trying to do is check that the number of agents ready is greater than 1. We comment the wait statement to reflect the code usage. By the way, don't worry about writing all this down. The final code is going to be provided in the description of the tutorial. Another interesting thing about this wait statement is the for loop. We use this MADARA shorthand for a for loop to specify a control structure that increments a variable I from 0 to 5. It then uses this variable I as part of the variable expansion agent I.ready, which is in turn used to check global variables for truth. This truth check is what determines whether or not we increment the local variable agent's ready. When you get a moment, take a closer look at this code to make sure you understand how it works. We compile and realize that some of the code we copied references a variable I that doesn't exist here, so we change that to reference command line argument 1 specifically. Now our wait statement is complete and compiled. To test our networked application, we run the code in 2 terminals. One has an ID of 0 and the other has an ID of 1. As you can see, the barrier is successful, but the MADARA engine warns us that we do not have enough room in our network buffer to transmit and receive these large files. The problem here is that the image is 52 kilobytes, but the default transport buffer length is only a fraction of that. We fix this problem by making the queue length bigger in our transport settings. Let's set the queue length to 100 kilobytes, which is plenty of room for a single image. We compile the application again and rerun the application in both terminals. This time, MADARA doesn't warn us about buffer sizes. Right now, each agent is setting the same image variable. Let's provide a way to differentiate which image was sent by which agent and add some metadata for our image that we'll send to other agents. We'll add image.size, which uses a MADARA system call #size to check the size of the variable image ID. MADARA provides many system calls that can help you query system and variable information such as type and size. To see a list of these system calls, run system calls from the bin directory inside of the MADARA installation, or you can invoke #print system calls from inside an evaluate or wait statement. If we sent all of this metadata separately from the image, it may cause confusion and invalid state, so we'll create an eval settings class that allows us to delay the sending of modifications until we explicitly say it is safe to aggregate a message to other agents. In the eval settings class, we change two settings to true. These specify that we want to expand all variable names like image ID and that we want to delay sending modifications. To send the aggregate packet, we can call send modifieds on the knowledge base, or we can simply call some mutating operation like evaluate, wait, or set with default evaluation settings. Here we choose to explicitly call send modifieds. At this point in the execution of the program, the variable image_id and image_id.size will be aggregated into a single packet that will be sent to anyone that is properly set up to receive the message. Another quick compilation and we're ready to try our modified program. So far so good, but we're only using 2 agents. Let's try increasing the coordination to include 4 agents and see what happens. To do this, we increase the number of agents ready required in the wait statement to be equal to 4. Now we launch an additional 2 terminals and provide them with the IDs 2 and 3. Then we try to run all 4 agent applications, but we have a problem with one of the agents. The terminal with ID 0 does not appear to have passed the barrier. The problem here is that the 100 kilobyte queue length we specified earlier is not appropriate for 4 agents sending these images. If the underlying operating system receives 3 of these 52 kilobyte images at the same time, before we can remove any of them from the multicast transport, the multicast standard allows the operating system to drop the packets. Again, we have an issue where we did not specify enough queue length. To fix this issue with important barrier messages being potentially dropped by the operating system, we set an additional agentID.ready evaluation to true, and we increase the queue length to 400 kilobytes. Obviously, for agents in a wired network on PCs, you can probably get away with much larger buffer sizes, but MADARA was developed for real-time systems and by default uses very small buffers. Feel free to specify megabytes of buffer space if you have the memory available. We compile the program and run the agent applications again. This time, all agents get through the barrier and receive images before they print their knowledge and exit. However, not all agents receive all 3 images from the other agents. However, adding an additional read file and metadata evaluation does get all of the images to each of the agents. All 3 UDP-based transports in MADARA offer best effort messaging that does not guarantee reliable delivery. This is because reliability is often difficult to enforce in real-time scenarios. For instance, using TCP in a wireless environment can cause the calling application to block indefinitely when collaborating agents go out of range of each other. Consequently, MADARA by default assumes that it is being used in a continuous environment where important information is resent periodically. MADARA developers can create reliability in their applications by requiring ACK messages from other agents. For instance, in the application we just created, we could have added another wait statement that specifically waited for 3 variables called agent_i.receivedImage to be non-zero or true, and resent the image until this received image condition was also true. We also do provide limited support for DDS transports, which do allow for reliability to be toggled on in the transport settings class. So what are some takeaways from this tutorial? Well, first, transports are best effort by default, but you can use acknowledgments to make sure that important information was received. Also, default buffer sizes are adequate for most primitive types and control messages between agents, but you will have to increase queue length for sending images in larger files. We went over some pretty advanced topics like barriers, but despite the power of these features, implementing them in MADARA can be pretty concise and straightforward. Additionally, MADARA allows developers to aggregate related information like metadata into the same knowledge update packet for consistency. And last, there are many example applications in the tests and tutorials directories that may be useful to developers starting out MADARA. As always, be sure to check out our MADARA website and YouTube channel for more information and guides on MADARA.